All right, we're going to take a look at some simple data types. And first we're going to look at Booleans, which are a binary variable, meaning it has two different options. And those are going to be true or false. And very often you'll see Booleans used to determine which chunks of code will run. For instance, in an if-then statement, one section will run or another depending if something is true or false. Next one is strings, which are just a sequence of characters. For instance, dog here is just a sequence of characters encapsulated by double quotes. And as we move down, we'll take a look at numeric data types. As you can see, we have all sorts of different ranges. Some of them hold a lot of different possible options. Some of them hold just a few. And the reason for that is just for better memory management. If you have a really big app and you want to be more efficient with it, you knew you're only going to use positive numbers, you might use an unsigned integer. Or if, say for instance, if your range was going to be between -128 and 127, it was never going to go outside those bounds, you could save a lot of memory by using an int 8. So obviously the signed 8-bit integers have a negative and positive value, while the unsigned integers like unsigned int 8, these are positive, 0 and positive values. So obviously the more bits you use, the more different possibilities. One thing to be aware of on unsigned int, like for instance 2 to the 8 is actually 256. They wanted a placeholder for 0. That's why it's 255, because we had to use one of those spots for 0. Now, like I was mentioning, you want to make sure you don't go outside the bounds of what you're using it for. So let's go ahead and go down to the editor. And here we have variable a, which is an int 8. And we're going to attempt to assign the value 200 to that data type, and this should run into an error, and it does. 200 overflows int 8, which makes sense because, as we had mentioned earlier, the range is only from -128 to 127, and obviously 200 is much higher than 127. So something to keep in mind. Moving on to floating points. Floating points can be used to store anything with a decimal component. We have float 32s, which have 32 bits of memory, and we have float 64, which occupies 64 bits of memory. So even though the float 64 will take up more memory, it does have a higher level of precision. And if you really wanted to go even as imaginary numbers, if you remember that from math class, we have a complex 64 as well as complex 128. And we're going to take a look at another function, the printf, out of the fmt package. Let me switch directories here. And as you can see, we have 5 different variables. Variable A is of type bool, variable B is type string, variable C is type int, variable D is type float 64, and variable E is of type complex 128. So reading this from left to right, look inside the fmt package, find the printf function. You're going to take 2 arguments. Here's the first one and here's the second. And the first one is a string, and it's going to be looking for particular verbs. Like this is the type verb, and it's going to go ahead and find the type of A and replace this section right here with that type. And looking at the \n, that's just the new line character, so we can put these on different lines. The function we were using earlier, the print ln, fmt.Printf, that one creates its own new line. This one we have to put it in ourselves. Let's go ahead and run it. There we go. A of type bool, B is type string, C is type int, D is float 64, and E is complex 128. All right, I'll see you in the next one.